All right, guys, how we doing? So, as you recall, proving triangles congruent was a pretty big part of the curriculum. And you probably spent a lot more time doing proofs than you probably ever wanted to. But such is life, and this is one of the things that we had to focus on. So, I'm going to start off by just talking quickly. Remember, rigid motion. We kept talking about that during transformations, and I'm sure you did so during the year. But a rigid motion is some kind of a transformation. It's not going to change the shape. Right? Your pre-image and your image have to be congruent. So if you think about it, like what's really going to be the same? Would they have the same area? Of course they would. They would have the same perimeter. They would. But you're not really going to focus on that as much as you're going to focus on the sides and angles, the parts, right? Parts of a triangle. So if I ask you how many parts does a triangle have, naturally your thought goes to 3, but really you want to think of that more in terms of 6, where there's 3 sides and 3 angles. All right? Now we're going to connect that word from a few days ago, corresponding in. So the corresponding angles when we did 2 parallel lines cut by a transversal, where this angle here and this angle here, top right-hand corner of the cluster, top right-hand corner of the cluster, they were congruent, right? Top right, because they are corresponding and the lines were parallel, even though mine are a little off. All right? Same concept now here within triangles. So what I want you to look at here is I'm telling you these 2 triangles are congruent. All right? So you got this triangle on the left and this triangle on the right. Now, if they are congruent, I want to try to match up the sides and angles that would be congruent. Now, the easiest way to do this is to think about it in terms of a transformation. What would I have to do to this triangle to make it turn into this triangle? And after a little bit of discovery and thinking and bouncing off each other, we would come to the conclusion that if you flipped it over this line CD, this line segment, flip, aka line reflection, the one would map onto the other. Right? We talked about line reflections being rigid motion, so I know that the pre-image and the image would be congruent. Right? So if we looked at this, what side would be congruent to AC if you flipped it over? And the answer, as you probably suspect, is BC. So that's the first thing I'm going to write here, would be that AC is congruent to CB. All right. And what would be the next pair of sides I can talk about? Well, maybe the next pair of sides you see is AD. Well, AD, its corresponding side would be on the flip, DB. So you would know that AD is congruent to DB. All right, but you know there's 3 sides. All right, so where's that third pair of sides? Pair of sides. All right, and what you hopefully come to the conclusion of is, wait a second, I got CD is one of the 3 sides, but it's also here. So this is a shared side. All right, and for those of you who even a little bit followed with the proofs, what should be in your head right now is an R word. Do you remember that R word? Reflexive. All right, reflexive is a property that indicates that anything is congruent to itself. All right, 5 is equal to 5. Cuccinello is congruent to Cuccinello. CD is congruent to CD. Anything's congruent to itself. All right, so those now are the 3 pairs of corresponding sides because these triangles are congruent, and apparently it was a result of a line reflection. Now, but that's not it. That was 3 of the 6 parts. All right, up here, 6 parts. All right, so what you want to look at now is the angles. So what angle would be corresponding to CAD, or angle A, you can call it there? On the flip, oh, that's angle B. All right, so you can state that angle A is congruent to angle B. All right, and then there's 2 more pairs of angles. Where you got this angle down here. These yellow dot angles. Oh, the yellow dot angles, that's angle, I can't say angle D. I need 3 letters on that, right? It's not just a point there. So I'm going to call it ADC, Angle ADC is congruent to angle ADC, BDC. And then finally, the remaining angles here, my orange dot angles, I can say are also congruent. Angle ACD is congruent to angle BCD. Just be careful. A lot of kids look at ADC and ACD and they think it's the same angle. But remember, that middle letter is your vertex. So A to C to D, ACD. All right, this angle right here and this angle right here. All right, so you got to be careful. That middle letter, remember, is your vertex angle. All right, so that's how you know, that's what you can know if you know these two triangles are congruent. But the truth is, and maybe you remember this and maybe you don't, to prove triangles congruent does not rely on you or require of you to get all 6 parts to be congruent. Those triangle proofs would be horrible if every single one you had to prove all 6 parts are congruent to all 6 parts. All right, and you might say they're horrible anyhow, but you know, some people like them. All right, but the reality is that there's more streamlined ways of proving triangles are congruent, and that's going to be the focus of the second video. All right, so what do I want you to get out of this? All right, as long as you have 2 congruent triangles, all 6 corresponding parts are going to also be congruent. All right, that's what it means for 2 triangles to be congruent. All right, so sit tight, next one coming up.